Okay, so some important vocab that you need is the number out in front of a radical is just going to be referred to as the coefficient, and then just remember from last week, the number inside the radical is called the radicand. So when you're multiplying radicals together, you can multiply coefficients, so any numbers out in front can be multiplied together. Radicands, so numbers inside the radical, can get multiplied together. And then lastly, if you can simplify the radical, you want to do that. So again, numbers out in front can be multiplied together, numbers under the radical can be multiplied together, and then lastly, you can simplify the radical if you need. So here's the first few examples of multiplying. So for this first set, since these numbers are both in the radical, you can multiply them together. So you end up with square root of 80, because 8 times 10 is 80. And then you want to use your list we made. So remember, we made that table, and you're looking for a perfect square that goes into 80. And you want it to be the biggest perfect square you can find. So if I looked through my list, I should be able to figure out that 4 would work, but 4 is not the biggest. The biggest option is really 16. So 80 can be rewritten as 16 times 5. The square root of 16 is actually 4. Carry this down. You just always want to double check, can you simplify this further? You cannot, and so the final answer would be 4 square root of 5. So the second one, same idea. Since these numbers are both in the radical, you can multiply them together. So 2 times 26 is 52. So this is really square root of 50. What perfect square can you divide 52 by? And when you're looking through that list, hopefully you could figure out that it was 4 times 13. Square root of 4 is actually just 2. And then you carry this down. You would want to double check, is there a perfect square you can divide 13 by? And there is not. So it would just be 2 square root of 13. So then here's another example, and this one's slightly different because there are coefficients out in front. So just remember, any numbers out in front, the coefficients, can be multiplied together. Any numbers in a radical can be multiplied together. So 4 times negative 2 gets me negative 8 out in front. 12 times 75. 12 times 75 gets you 900. The square root of 900 is actually on your perfect square list. So square root of 900 is actually 30. And then lastly, you multiply those two together. So negative 8 times 30 is negative 240. Okay, so here's the first example. So the first thing I told you is you need to write it as 2 separate radicals. So I don't want one big square root. I really want it to look like this. Okay, so I have one radical in the top and then one in the bottom. And then if you look at those, they're actually perfect squares. So the square root of 64 is really 8. The square root of 49 is really 7. Same idea for the second one. So I want to rewrite, I'm going to put this one down here. I'm going to rewrite it, so I want square root of 144 in the numerator and square root of 9 in the denominator. And then again, if you check your list, these are both perfect squares. Square root of 144 is really 12. Square root of 9 is really 3. And then this can go one step further because 12 divided by 3 is actually 4. Okay, so for this one, they're already written as 2 separate radicals, so that's fine. Now, these numbers out in front, 2/6, can really be rewritten as 1/3. Does that make sense? Perfect. Okay, you can simplify 2/6 and make it 1/3 right here. if this didn't have radicals and it was just 12 over 3, you would tell me 12 divided by 3 is really 4, right? So the same thing happens. Just because these are in square roots, you can still simplify them. So square root of 12 divided by square root of 3 is square root of 4. Okay, so it simplifies just the same. So really what that tells me is up here I have a square root of 4. Then you can just keep simplifying. So square root of 4 is actually 2. 1 times 2 is 2. So this is really 2/3. So basically, anytime you have a fraction, if it's just normal numbers like out in front, those can be simplified. If it looked like, 8 over 4 and they were in square roots, they can still be simplified. So 8 divided by 4 is 2. Since it's in a radical, it stays in a radical.